Good morning, and welcome to the 2023 Harvard Radcliffe Institute Science Symposium, Feeding the Future, Food Sustainability and Climate Change. I am Immaculata DeVivo, co-director of the science program at Radcliffe. I'm also a professor of medicine at the Harvard Medical School and a professor of epidemiology at the Harvard School of Public Health. We are pleased to have all of you join us today, both in person and virtually. And to kick things off, I would like to introduce our dean, Tomiko Brown-Nagin. Dean Brown-Nagin had planned to be here in person, but there was an unexpected call out of town yesterday, and she has kindly recorded her welcoming remarks, and we will play for those remarks now. Thank you and welcome.
Good morning. I'm Tomiko Brown-Nagin, Dean of the Harvard Radcliffe Institute, and it is my pleasure to welcome all of you in person and online to Radcliffe's annual Science Symposium. This year's convening is part of our climate change initiative, which applies Radcliffe's interdisciplinary lens to advance our understanding of the complex causes of and solutions to the climate crisis. We're proud to join colleagues across Harvard University, including the Saha Institute for Climate and Sustainability, to address one of the most important issues of our time. Our conference began yesterday evening with a keynote co-sponsored by the Saha Institute, by James Beard Award-winning chef, restaurateur, and zero-waste cookbook author Irene Xian Li, in conversation with WBUR's climate and environmental correspondent, Barbara Moran. It was a thought-provoking discussion, and a recording will be available on our website in the coming weeks for those who missed it. Today, we'll continue to explore the pressing issue of climate change and food sustainability. The urgency of the climate crisis has been readily apparent in recent months. Extreme weather events have sounded alarm bells of a planet on the brink, according to one headline. Dangerous heat baked much of the globe, and the World Meteorological Association declared this past June, July, and August to be Earth's hottest 3-month period on record. Sea surface temperatures climbed to record heights, and punishing storms, deadly floods, and catastrophic wildfires have devastated communities around the world. These disasters have placed in stark relief what the future may hold if we fail to implement robust adaptation and mitigation strategies. And as today's panel will illuminate, the global food system is a critical part of these strategies. It's a system that begins with production, from farming crops to raising livestock and harvesting fish. From there, food is processed, packaged, and transported for people to prepare and consume. And all along the way, a portion of our food is lost or wasted. This has substantial environmental impact. One study estimated that in 2015, the global food health system emitted 18 billion tons of carbon dioxide equivalent, which accounted for 34% of all greenhouse gas emissions from human activity. Meanwhile, the food system consumes energy and requires a significant share of Earth's natural resources, including land and water. Yet, even as the global food system contributes to our warming planet, climate change also threatens that system, with anticipated effects on the amount, price, and nutritional value of food we're able to produce to feed a growing population. Indeed, climate change is expected to shape what the Intergovernmental Panel on Climate Change described as, quote, the 4 pillars of food insecurity, namely availability, access, utilization, and stability. What's more, these threats are not born equally. Impacts differ across lines of gender, race, ethnicity, occupation, geography, and socioeconomic status. And at the global level, many of the countries that have contributed the least to greenhouse gas emissions are now most vulnerable to climate change. As several of my Harvard colleagues wrote in the annual review of public health, ensuring adequate nutrition for all in the face of environmental limitations and the climate crisis will be, quote, one of the great humanitarian challenges of the 21st century. This is our focus today. Together, we will explore connections between the food we eat and climate change, as well as the profound challenges of addressing the climate crisis while feeding the world's population equitably and healthfully. We will begin with a panel on food production and transportation in the context of climate change, followed by a discussion of food preparation and consumption. We'll then break for lunch, when those of you attending in person will also have the opportunity to view a student poster session and a community ideas fair about the themes of today's program. Free boxed lunches are available for all present today. After lunch, we'll reconvene for our third and final panel about food access and security. We welcome your questions throughout the program. Whether you're watching in person or online, you can submit questions using the Slido link that is provided on the screen and posted in the chat feature of the Zoom webinar. Now, before we begin our first panel, let me offer some things. First, I'm grateful to the distinguished group of panelists and moderators joining us today. Thanks to all of you. I also want to thank Radcliffe's Science Program faculty co-directors, Professors Immaculado De Vivo and Ido Berger, who planned this convening in consultation with colleagues across the university. Thanks as ever to Rebecca Wasserman, Executive Director of Academic Ventures and Engagement at Radcliffe, Jessica Vicklin, Director of Events, and their entire teams. Let me also acknowledge the Salata Institute for Climate and Sustainability, Radcliffe's Melanie Mason and David W. Nemick Fund for Science, and the Ethel and David Jackson Fund for the Future Climate, which are all supporting the symposium. I also want to thank members of the Radcliffe Institute Leadership Society and all our annual donors. Your generosity keeps Radcliffe's lectures, conferences, exhibitions, and collections free and open to the public, and I thank you. And finally, thanks to all of you who are joining us today, whether virtually or in person. With that, I'm pleased to kick off our first session, which will be moderated by Dr. Sparsha Saha. Sparsha is a lecturer in Harvard's Department of Government and is the only empirical political scientist who studies meat politics. Her research focuses on political behavior, and she uses experiments to examine how voters respond to political attention on animal rights, meat, and related topics. Her work has appeared in numerous scholarly publications and has been covered by a variety of media outlets, including the New York Times. Now, please join me in warmly welcoming Sparsha and their panelists to the stage.
Hello? Yep, there we go. Hello and good morning. I will be moderating our first panel today on food production and transportation. My name is Dr. Sparsha Saha, and I'm an experimentalist and political scientist. As you heard, I study the politics of meat and the role of gender in elections. I teach Harvard's Food Systems and Politics course at the Department of Government, where I'm also a lecturer, and it's called The Great Food Transformation. And on that note, shout out to the students of Great Food Transformation last spring, all my former students, and especially my current students in my seminar on animals and politics who are watching right now. You are all of you bright and inspiring. Thank you so much for being my students. The challenge of feeding growing human populations healthy and sustainable meals as climate change worsens, impacting soil, water, and crops, not to mention supply chains, animals, farmers, and workers, is one that will mark the 21st century. It is a tall task, but one that I feel we are up to, particularly given the bright and dedicated experts on our panel today. Professor Diane Beckles from UC Davis, Dr. Mengyu Li, who is with us virtually from the University of Sydney in Australia, and Dr. David Hughes, who is the chair of Global Food Security at Penn State College. Our session will start with remarks from each panelist, followed by a moderated conversation, and then Q&A. Audience members are welcome to submit questions at any time during the session, and we promise we will get to as many as we can. Whether you are here in person or watching online, you can submit questions using the Slido link, which is on the screen behind me, and also posted in the chat of the Zoom webinar. So we'll start with Diane, who I invite to share her remarks.
Hello. Hello. So today I'm going to tell you a story of the production and transport of food, specifically focusing on specialty crops. So these are nutrient-dense fruits, veg, leafy greens, the kind of things that can spoil easily, but which are necessary for good health. And there's so much I wanted to tell you today. My slides are all over the place because I could not make up my mind. So please forgive me, but hopefully we can have a conversation. So I want to start our story going back to hunter-gatherer ancestors, and I want you to think about the way they had to search for food. It was sparse, it was scarce, and they had to travel, many miles. And contrast that today, fast forward thousands of years, our food is dense, plentiful, and it actually comes to us. Food travels many miles, and this is quite remarkable. So for most of our time on Earth, we were hunter-gatherers, about 94% of that time. And what's even just blows my mind is that food can travel globally from the site of production to the consumer. And it's not a straight path from farm to house, but there's all these entities that, the food may need to have to travel in order to get to the consumer. So we're very sophisticated in our consumption of food, and this sophistication is necessary because for specialty crops, they're still alive at harvest. They are able to respire, transpire, genes are being expressed, so it's really a charge to keep this fruit and vegetables alive, and we can do this through technology. It's remarkable, and I'll keep using the word remarkable because I can't almost believe what we're able to do as human beings. But there's a tragedy. As mentioned, a lot of fruits and veg are lost along the way, as much as 30%. Some of it is lost incidentally because the fruit and veg can spoil. But tragically, in many developed countries, we actually throw food away that's perfectly edible, but it may not meet our needs in terms of what it looks like or what it tastes like, and so we just throw it away. And this is a tragedy given the challenges we have with agriculture, global warming, and this is where I think science can help. So how do we make the production and transport of these fruit and veg sustainable? And my answer to this would be technology. Yes, there are other factors, politics, economics, social. I'm a scientist and I focus on scientific solutions. So production in the field, challenges of reducing resources, limited access to water. So there are attempts to use technology to make the production of food as efficient and as profitable as possible. We try to maximize yields, and at this stage for specialty crops, we're also trying to maximize quality, because after harvest, there's nothing we can do about quality. It all happens in the field. And so there's drone technology, sensors to determine how much water to apply to plants, drones for use of monitoring how the plant health is in the field, and this is all necessary and important. And then at harvest, we also use technology for sorting, grading, and this may not seem like a big deal, but having a machine to determine the stage of readiness of harvested crops is important because it helps to divert or channel the produce appropriately, either to restaurants or to stores or to a farmer's market. And transportation. There's a move towards having these high-tech, high-efficiency trucks with sensors that monitor fruit and veg as it moves from the field towards the consumer. And these sensors are able to transmit information about the state of the produce to the internet, where that information is monitored as well. So it's like having an Apple Watch on your apples or something, so you can monitor constantly the state and quality of that particular fruit. So we've got all this technology available for maximal production, yield, quality in the field, for monitoring and sorting, and also for ensuring adequate transport. But what about the fruit and veg themselves? We're in the 21st century. We need to have high-tech fruit and veg as well. And this is where I come in. I'm a biotechnologist. I'm interested in understanding the genetic makeup of produce in order to make changes so that they match our needs. And this is facilitated by our knowledge of the genomes of organisms. It's really cheap to sequence a genome right now. And whereas in the past, our hunter-gatherer ancestors had to rely on nature for generating random mutations in the genome or genotype of individuals, we have the knowledge to make more specific changes. So if you look at this, what you're seeing here is the natural or wild banana. I hope you can pick out what was the original carrot, not very productive, natural, very nutritious, but it wouldn't work in our modern society. This, ladies and gentlemen, are the fruit and veg that we consume. They've all been genetically modified through thousands of years, starting with these natural mutations and built up with scientific application of our knowledge of genomes. And we have to go further. We have to further adapt these fruit and veg for our modern lifestyle. And so if we start at domestication with natural changes in the genome, we can see that over time, through our knowledge of genetics and genomics and biotechnology, we've been able to make more targeted and specific changes so that we can have more control over how our fruit and veg will behave. So a little bit of a genetics lesson. So if you look at, I hope I don't lose you here, but the DNA contains the blueprint of our life, what determines traits, form, and function. And if there are mistakes in this code, then that can lead to changes in amino acids, polypeptides. And those polypeptides are sort of the workers in the cell. They determine what things look like, how they function, etc. So from a fruit and veg perspective, taste, flavor, shelf life, and so on. So if we have like a simple substitution or a single deletion of one letter in this code, it can have consequences for the protein and thereby consequences for traits that we value. And so what we're able to do with some of the modern technology like gene editing is to use our knowledge of the sequence that determine traits and just make small tweaks or changes to that code and hopefully have a trait that we're interested in. So here's a potato. My lab studies potato. There's about 3 billion base pairs or nucleotides, 3 billion pieces of code. And we may only need to tweak one out of that 3 billion to get a change that is desirable. So in my lab, we want to engineer crops for longer shelf life, better nutrition sustainability, and improve consumer traits. This is what's important. And we want to do this using biotechnology. And we're perhaps a little bit naive because we think that this can actually help the food system to become a little bit equitable. That may be debatable, but that's what guides us. That's our North Star. And so one of the things we study is post-harvest chill and injury. So it's unbelievable, but about 50% of the most popular fruit and veg should not be refrigerated. This includes things that we normally eat: bananas, bell peppers, basil, mangoes, avocado. Temperatures that we would have in our fridge is actually harmful. And so we study this, and one of our projects look at potato starch. So potatoes in the US are harvested once a year and stored at low temperatures. But if the temperatures are too low, the starch in the potato will break down to sugars. So you'll lose yield. But that's not even the problem. If you bake or fry those potatoes, you'll get the formation of these black spots, not nice to look at. They taste bitter. But they're also carcinogenic because it's acrylamide. So that's a problem. And the other thing about potatoes is even though they're nutritious, starch is pretty easy to break down once we consume the cooked product. Very high glycemic index. So what we're doing is we're modifying the starch. We're using our knowledge of that starch that's accumulated in potato, attacking certain enzymes that make the starch to make it harder to break down. And we think this can be important for a lot of communities because some of the poorest people consume a lot of potatoes. And what we could essentially do is increase the apparent fiber content. If the starch is hard to break down, it will act like fiber. So who is adopting this gene editing, this technology that allows us to make specific changes in the genome of fruits and veg? Well, China is investing heavily. African countries, they're using this technology for crops that are important to them. And small and mid-sized companies in the US, they're able now, because the technology is pretty cheap, fairly easy to use, things like making strawberries taste better, firmer, raspberries, having them be more resilient along the supply chain. These are things that are possible that weren't possible before, and traits that could reduce waste and loss and, have the consumer be happy. So one of the things about agriculture is there's the humanitarian side of things, but the industry has to be profitable, and sometimes that's not always, it doesn't always match with what we need to do to protect the environment and to deliver healthy crops to people. So the traits and some of the crops that we focus on may be designed for making more money. Things like importing fruit and veg out of season, we do that because it's profitable. And there are food deserts in the United States, so it's easier and more profitable to ship food halfway across the world, but we haven't figured out a way to get this nutritious food into some cities in the United States. Loss and waste could be reduced if we could sort of have food moved to people instead of to landfills, but that requires cooperation from people, and sometimes we're a little bit of a problem as well. So to summarize, I would just say that forget the words on this slide. I'm a scientist. I do believe in the power of science to help solve some issues with food security. Yes, we may have been sort of problematic in the past, but we've learned and we can progress. I'd like to acknowledge some of the slides that I used were from the Produce Management Association here in my lab, and I'm happy to answer any questions at the appropriate time. Thank you.
And many thanks to Diane for her presentation. Next, I invite Mengyu to share her remarks.
So thanks so much, and hello everyone. Thanks for an opportunity to participate in this amazing program. I'm Mengyu Li, and I'm now a postdoc researcher from Integrated Sustainability Analysis Group at the University of Sydney. And in ISA, my research is to assess sustainability impact at local, national, and global scales. So in the following, I will talk about our recent work on quantifying the carbon footprint of global food miles that was published in Nature Food a few months ago. So an overview of my presentation, I will start with a distinguishment of food transport versus food miles. And then I will talk about the underlying model that enables this study, and followed by some results and discussions. So in the latest 20 years, we see a fast growing percentage of food being traded. And global food trade is important. It provides nutrition access around the world. But at the same time, it relies on fossil fuels during transportation so that environmental impacts are caused directly from global food trade. And when we measure such environmental impacts, there actually exists different definitions and scopes. So one can use, for example, food transport emissions to describe emissions associated with the transport of a certain food product from its production to consumption. Example here is, for example, the red meat consumption in China. Then food transport emissions would incorporate emissions when we transport red meat, for example, from the meat manufacturing industry to households. But at the same time, we know that red meat production would also need to draw input from other sectors, such as fertilizers, fuels, machinery. And all those inputs, they would require transportation as well during their deliveries. Then if we further include transport emissions associated with the entire upstream food supply chain, we're actually looking at a concept from food transport now to carbon footprint of food transport, which we can call it food mile emissions. And our work aimed to look at food mile emissions at a global scale. And there are actually important reasons to do so. If, for example, we look at the monetary cost of our food, that is the money we pay to buy food, such cost has already involved all upstream sector transport cost, not only the transport cost for food itself. For example, if we look at fluctuations in the global crude oil price, then such fluctuation would actually lead to fluctuations in our food cost as well. And in order to really align the monetary scope of food, so in this study, we are interested to see what would be the additional information on food mile emissions that include transport emissions from the entire upstream supply chain. And for doing such quantification, we developed an integrated tool to enumerate impacts of food transport from the entire supply chain network. And specifically, this tool integrates three perspectives. Firstly, transport activities that describe physical transport of commodities, and then combined with global food trade network that really integrates global food consumption and also the supply chain network. So those three components are actually telling us a full picture from food production to food consumption through the transportation system. And for the food transport network, it was captured by the so-called input-output model. And this model can record transactions among different sectors between different regions. And such a model is developed within our industrial ecology virtual laboratory, which is a collaborative cloud-based research platform that we have developed here at Uni to enable compiling large-scale multi-regional input-output tables following users' preferences. And based on this integrated framework, we finally got a tool to look at the carbon footprint of the global food miles. So this graph here shows an overview of the magnitude of the carbon footprint of global food miles. And by considering the entire supply chain, we estimated this carbon footprint of global food miles could reach 2 to 3 gigaton, depending on different assumptions or different parameters. And to put such number into perspective, this is representing 13 to 20% of the entire food system emissions. And this middle pie chart here shows such breakdown by different sectors. And we can see the green section, that is veggie and the fruit sector, really contribute to a higher percentage. And this is largely due to the, for example, cooling requirement during transportation, and also the high tonnage consumed worldwide. And if we further look at the spatial contribution, we can see that large economies such as China, the States, and Europe are really contributing the most. But if we look at the per capita basis to the right-hand side, we can see some interesting trends if we break down such contribution by domestic and international component. So domestic variation, which is left side of the bar chart, is generally mild and is more related to countries' area. For example, North America, East Asia, and Oceania, those regions are with larger area, so they are actually top in the ranking. And if we move to the right, international food mile emissions are more related to income levels. We can see rich regions such as Europe, North America, and Oceania, they contribute much higher per capita international food mile. And this could be mostly related to a higher percentage of imported food and also traveled with long distances. And we can also use into specific food supply chains. So here is an example of the red meat consumption in China. So here we have circles, we have arrows. Circle values represent production-based emissions. And then arrow values are the transportation-related emissions. And if we start from the domestic supply chains, we can see that circle values are actually much higher than arrow values. And this means production-based emissions are of higher magnitude when we look at domestic supply chains. But this is not really the case for some long-distance supply chains. For example, the soybeans from Brazil to livestock sector in China, we can see transport emissions and production-based emissions. That is, the arrow values and circle values, they are of very similar magnitude. And this indicates really it is important to distinguish the origin and destination of global supply chains and really include the upstream supply chains when we quantify food mile emissions. So this slide further shows the contribution of food mile emissions by different supply chain layers. So starting from layer 1, it can be regarded as transport emissions for meeting our direct household food consumption. And then layer 2, layer 3, and so on, they refer to upstream supply chains. And we can see that impacts almost doubled when we expand from direct food consumption to upstream supply chain network. So some reflections here. Clearly, we can see when we expand our conversation to the entire supply chain, we show that footprint of food miles and their emissions, they matter. And then the next question logically is how we can reduce food mile emissions. Of course, there exist options for, say, technological improvement. Say we expand the use of clean energy carriers and also vehicles. Then the other question is how about localization? So the answer is yes. So we show that localizing food supply in an international context, that is, consider a hypothetical scenario where every country does not import any food from the other countries. And then this leads to food mile emissions reduction by roughly 10%. And this reduction appears to be limited, and this is mostly because we would need to substitute low-emission maritime shipping with domestic truck transportation, and the latter are actually with higher emission intensity. And clearly, 10% is not enough. So Here, when we look at the entire supply chain, we further call for the engagement of different actors at different supply chain stages, including wholesalers, including retailers, investors, governments, and finally us consumers. In other words, we all need to be part of the solution. So thanks very much. Any feedback, you are very welcome to contact me through the email address here. Thank you.
Thanks so much, Mengyu. Last but not least, David, please take it away whenever you're ready. Oh, yeah, absolutely.
Hi, good morning, everybody, and thank you so much for this very nice invitation to be here. So I want to discuss our model of planned village, which is what we think is to be the necessary component to be able to meet global food security under climate change, and particularly for those individuals in the global south. So let's start with an imagination game. Imagine a country where the average life expectancy is 40 years old, where child mortality is roughly 1/3, where less than 5% of people have access to indoor plumbing, 52% of your income is spent on food, very little government help, a lot of cronyism which is inherent in the system. What country is this? And this country is America in 1855. And this was when Penn State University began as a land grant or a farmer's school. In 1862, we had the land grants. We have a colleague here from Vermont where Senator Morrill instigated the new system, a new system of universities. So I was at Harvard here at the Museum of Comparative Zoology at the time, moved to Penn State, and was blown away by what America had created. And before that, I was at Oxford, and see these large historical universities are ill-fitted to the problems at hand. In the 1860s, it was ill-fitted to the problem, which was a growing population moving out westwards, needing to feed, needing to grow our cities. And the extent to which the practical research from the land grants helped is an historic lesson, because we need that lesson today as we think about ways in which we are going to feed 10 billion people in a world that is 2.6 degrees Celsius above historical norms. So we heard about potatoes, so I'm Irish. So in 1847, we had this situation. Predominantly women, so we're in the Radcliffe Institute, predominantly women, bent over shovels, low technology, pulling tubers out of the ground, potatoes in this case. This is Africa today. We have moved forward, but they are in stasis. So hundreds of millions of predominantly older women who are working in subsistence agriculture despite the technology that we have, like our phones and Zoom and everything else. This is Ambassador Kip Thom, the ambassador to the UN agencies in Rome, and this is a picture he took, 2,800 years of stasis. So we have left Africa behind, and there's a lot of choice in there, and we can talk about choices around that. Agriculture has accelerated globally. Not necessarily a pretty picture, but one that demonstrates the impressiveness of mechanization in North America, or the high productivity gains we can have in our system. And this anonymous lady used on countless websites across the web to raise donor funds is on the banks of Mount Kenya, and she's using a tool which is unfit for the occasion. The tool, incidentally, is on the front of our brochures for this conference, a hoe, and it doesn't help her in climate change. We don't know her name, but we know this lady. This is Madame Felice, and she's with Faith Aroni here, which is a daughter of one of our first farmers we worked in Plant Village, and she was Madame Consolata. Faith is our gender specialist, and she's interviewing Felice. Felice has 5 children, 7 grandchildren, no husband, and she tends 1/4 of an acre of land, and she has to spend 2 weeks with that hoe ploughing the ground in order to be prepared. So the situation has not moved forward. And so the ways in which we're moving it forward is by giving supercomputers like this one to Rosalind Okoche in the foreground so that she can act as a bridge to her neighbor Emiliana in the background. And this is a convolutional neural network, an AI system working inside the phone that is twice as good as humans. So it's twice as good as the available humans. But the problem with systems in Africa is we have very few experts in the field. So the ratio between experts, or extension workers as they're called, and farmers is 1 to 3,000 farmers, or 1 to 12,000 depending on the country you're in. And so oftentimes they don't even have gas to get in their cars to go out, or their motorbikes to go out to farms. So the encounter rate is very low. The way in which we push forward development in every industrial society in the world is through the patient, repeated exchange of knowledge at the farm gate. That was the same in Ireland in 1846 when we began extension, America in the Vandeleur system in the 1850s, Japan in the 1890s, America in the 1900s, and so on and so forth, India in the 1960s, China in the last 20, 30 years. So we need to have knowledge to the farmers at the farm gate. Just tangentially, because a lot of people here are interested in nutrition, and we had a wonderful presentation last night by the chef, this is where we take the AI and we can now use this to help determine, as well as humans, the nutritional composition of food. We're rolling this across Ghana and Malawi, Sri Lanka, but it's 1/200 the cost of a human in doing those follow-up studies. So AI has, of course, transformed everything we're thinking about. We bring AI to an analog world, to smallholder farmers, about 75% of which are women farmers, predominantly over the age of 55, extraordinarily low income, and we do that through bridges. So the young people are a bridge to technology, and this is our Plant Village Dream Team, over 270 of them now in 11 countries, predominantly young women, except in the patriarchal systems like in the Kenya drylands, where it's predominantly men because these are the ones who are pastoralists. But what we're doing is having women leadership in these roles, driving the change across the global community. And this came out of our experience in the desert locust crisis. I was at the United Nations for 2 years at FAO, and we had this huge crisis within a crisis. So locusts during the time of COVID, the normal system didn't work, the global experts couldn't move there, but all the people in the Horn of Africa were there, and the satellites still went over, and they still had smartphones. And so we were able to communicate to the airplanes in real time where the swarms were, and our work during that crisis was modeled on the DREAM teams, and we were able to communicate in real time to where the airplanes were and save food at an estimated value of $1.7 billion for 40 million people through the use of young people and technology in real time, telling experts where the problem was. So this is an AI-powered, cloud-enabled supercomputer charged youth who are acting as a bridge to the farmers. And because they are literally the sons and daughters of farmers, they have this implicit trust in the system, and they spend 5 days a week with farmers bringing that knowledge. But they're also connected to the global cloud of land-grant universities, FAO, CGIR systems, as well as the satellite insights that are so present and enabled. So what we do is have this real-time communication with them. We got money from Eric Schmidt, which allowed us to bring sort of Google-type thinking on objectives and key results to this global youth system, so they know how to work efficiently, and also we empower them with science and machine learning so we can train them to be better scientists and do better experimentation. Here's an example of that. So we talked about AI being computer vision. We do a lot of spatiotemporal work, so continental scale wide analysis of something called net primary productivity measured by satellites. Or of course, that great revolution we've all gone through with ChatGPT. So here you can see in yellow, we have in Swahili, it's translated to English, and now we have an answer from the computer based upon the corpus of knowledge. Now imagine if you combine those three things. So we have computer vision saying you have a black spot in your leaf and we think it's a problem. We then know the last 40 years of data on your field, and you can ask the phone a question, and then we can know what the right answer for the right location is. And then we can do that at scale across 40 countries, so we can collectively learn what the problem is and how we effectively deal with it. We also work with children, so we have these climate change clubs where we help with young people because, of course, that's so critically important in training them. We reach out to about 14 million farmers on TV and radio. We have a lot of in-person gatherings in order to reinforce that knowledge. We send a lot of information out on SMS. Most farmers are not, of course, using smartphones. We provide the smartphones, but they have feature phones, so we sent 20 million SMS messages in 2022. And then we print a lot of guides in local languages, and we hand these out at village fairs. Again, we're not doing anything new. This is what we did in this country since 1862. It's not rocket science. We're just doing it at scale. And we need to do it at scale because this is climate change. This is the nice example I have of climate change from that heat dome that sat over Vancouver about 3 years ago. Each day we saw a record breaking, and on the fourth day the whole town burnt down. We could have shown examples of this, which is Malawi after a 4-year drought, but largely nobody cares. It's this that actually maybe moves people's attention, but maybe it doesn't. This was New York 3 months ago, and we sort of moved on. This is New York this weekend. We might sandwich in the UN General Assembly or Climate Week, and I was there last week or 2 weeks ago for this, but it's remarkable how blind we are to the threat. And I was talking to a young person last night about this. This will make World War II look like a walk in the park, the coming threat. Because as the Dean said in her opening remarks, we've just gone through the hottest summer in history. It's in fact the hottest summer in the last 120,000 years. It will be the coldest summer for the rest of your life. That's how bad things are. So this is where we are. We talked about domestication of crops. We had this beautiful period for the last 12,000 years where things were very stable, very precise. This is where we could do all those experiments that Diane is talking about as humans, and this is where we're going. And there are fundamental big problems here. I mean, just in terms of heat shock for the plants. Above a certain temperature, they go into heat shock and you can't rescue it. It's a little bit like you having an appendix or lower back problems. There's an evolutionary quirk that makes it difficult to rescue this. We can think about plant breeding, but in the best cases, if we really cared, 7 to 10 years before we get anything useful, but we're not investing in that effectively. We need adaptation at scale today for these things. Luckily, good news, not to leave on a depressing note, change is cheap. So we've had a lot of philanthropic support, so we can put in water harvesting systems. This is a really nice thing that's been scaled up by Just Dig It, and we're doing it ourselves across the Asal regions, the dryland regions in northern Kenya, where you capture water through this very simple bunds, and of course you create local employment. Dryland farming, this is a system whereby we're putting in wick irrigation into extraordinarily dry areas of northern Kenya. I argue that if you can have golf courses in Phoenix, you can have food for people in Africa. It depends if you want it. So this is an example of this pastoralist community, 6 successive droughts, and now this women group, 100% women group, are selling vegetables. This is the Haroya Adibile, and she's now understanding she can grow vegetables. It was usually 7 miles on a truck. She couldn't afford it, and now she's an entrepreneur. And she's selling to her community, and especially things like folic acid-rich kale. So systems that are really, really impactful. So as an immigrant, I'm fond of the history. I really like Lincoln's second address to Congress. The dogmas of the quiet past are inadequate to the stormy present, and the occasion is piled high with difficulty. And we must rise with the occasion. As our case is new, we must think anew, we must act anew, we must disenthrall ourselves. And he said, only then can we save our country. And I would say, only then can we save the world and those people who are depending upon food security. And this is where we can have to think new systems for the current circumstance we're in. Thank you.
Thanks so much, David. We'll now start our moderated group discussion. And my first question is for Diane. And before I start, I'll just say that I have so many questions for each of you. So 20 minutes feels very short, but thank you for all of the work that you all do. And I view this as a conversation, so I'll direct a question to someone, but if the other 2 people have anything to add, I'll kind of look at you and you can tell me. So first question is for Diane. Your work, which is at the level of the plant genome, is extremely promising toward making supply chains more durable and resilient, and by reducing food loss and waste, something that really sits at the very foundation of food security around the world. And decades ago, humans using similar methodologies took part in the Green Revolution, and this was known as the Third Agricultural Revolution. This one saw truly massive increases in crop yields and agricultural productivity. You said when you started your talk, it really is incredible what we've been able to do, helping to feed additional millions upon millions of humans. All the while, some argue, deeply damaging biodiversity, soil health, and overall planetary conditions in the long term. What lessons do you think scientists have walked away with from that? Has it impacted your work or the field, which is similarly helping us make sure millions of people have food security in the future?
Okay, so what I would say is that the young people who are making the decision to become scientists are doing so because they want to change and they want to fix all of that. So that underlines everything that they're doing. So how does it manifest in an experiment in the lab? There are various ways towards that, but the thinking, the understanding, the need to do good, the need to secure nutrition for all, the equity, this is all being driven by the students who come into our program. And so I'm the director of the undergraduate biotechnology program. We do classes on ethics and global issues and, access. So this is intertwined in what we do. And we're also trying to do what you're doing here at Radcliffe, which is to have conversations with non-scientists, with social scientists. So we're always trying to put what we're doing into context. So at the same time, we can never know the impact of a technology or a new variety until we put it out in the field and see what happens. But at least we're aware, we're sort of watching, we're monitoring, we're having these conversations.
Yeah. Thank you. If any of the other panelists have anything to add. If not, moving on from the plant genome, but still deeply connected to food security and resilience, global food emissions. Mengyu, your article on global food miles published in Nature Food fills a very important gap in our methods on the life cycle analysis of food, in short, from farm to table. And you're able to calculate the entire upstream supply chain of food mile emissions. And you talked about this a little bit in your presentation, but when I was reading through your paper, knowing some of the previous research that comes to mind, poor NEMSEC 2018, where the understanding was, well, it really doesn't matter, transportation is lower, you reveal that actually it's quite large. Can you take us into the weeds a little bit on what that, with examples, what that upstream supply chain is and what it looks like?
I think the major innovation of our work is actually to put together upstream supply chains into perspective, because previously no such studies existing, and we quantify in terms of like when we really expand our conversation to cover upstream supply chain, the impact would double. So that's sort of the magnitude in terms of when we really put everything together. And examples of such upstream supply chain, I would take vegetable and fruits as example, because it is actually contributing more than 1/3 of global food mile emissions. And we can see, for example, why veg and fruits, like they are associated with really high food mile emissions. It's partly because the cooling requirement during transportation, and also because of the high tonnage consumed worldwide. So when combining all those factors together, we're sort of asking ourselves, how can we define low emission food system? And we've been talking about dietary chain. That's really important, of course. And what else can we do? So by really looking at entire supply chain perspective, that is sort of providing us the magnitude we can do in terms of, for example, if we localize our food production and consumption. And it also provides a window to show how consumers can play a role. I saw that, those are my thoughts on your question.
Thank you, Mengyu. I'm turning to arguably the key actor on the supply side, that's the farmer, and how they're adapting to climate change as they quite literally produce food security for us all. David, the Plant Village solution is simple yet so powerful. Farmers must upload crop type, location, and planting data for the engine to send out potentially farm-saving advice. This must have required so much training, especially in the early stage of setting up Plant Village. Can you tell us a little bit about some of the challenges you faced in kind of setting up this system?
Thank you so much. I guess part of the great challenge was the preciousness of scientists. So I was an evolutionary biologist from rainforests and moved into this agricultural space. Our incentive structure is to hold on to knowledge and not disseminate it for all the problems of tenure and promotion and so on and so forth. So we have misaligned interests. So a lot of the people who out there who would have had knowledge just simply were not sharing it. They were holding on to it. Also, the other problem related to your first question for Diane is the lack of a clear system by which people understand the nature of the real problem. And so my training was with a group in Cabby, and they had been working for the British government in the former Commonwealth nations for a long period of time, and they had deep domain expertise. And we're not recognizing this. We're not promoting people who go through and understand everything there is to know about avocado diseases. What we're doing is splashy science that gets attention in the short term. And we saw how a Nobel laureate yesterday was kicked out of her university, and her papers were rejected from Science and Nature because she was playing the long game and trying to understand fundamental drivers. So there's a huge problem in our academia about this, and that was one of the massive issues. We solved that by just not going to the scientists anymore and just ourselves going and collecting this at scale. Because if you take somebody fresh out of college who's 23 from a university in Kenya or Malawi where the unemployment rates are 60%, you get really, really good people. And then you can train them to collect the images you want. The machine learning part is quite easy because Google and Facebook and everybody else wants to get your money. So they're just improving all of the technology that's available. So we take advantage of that.
And just a second question, so there's information that the farmers upload. In the future, what other kinds of information do you hope to either gather from farmers or disseminate? Yeah,
so the field is called plant pathology since 1846 when it began in Dublin with the potato blight, and then Anton de Bari, a very famous German scientist. It's plant pathology. So the whole point is to do a post-mortem. And we would like to move towards plant health. So how can we be prophylactic? So in this case, how can we put something into the soil that helps reduce the diseases? Or how do we have practices which prevent that necessary coming in diagnosis and a problem? Also diversification. Don't put all your money in Bitcoin. Don't put all your money in maize if you're in eastern Kenya and you're expecting 400 millimeters of rain. Diversify, and there's lots of things that we can do. In our case, we're putting in fruit trees which have this increased water holding capacity through probiotics in the soil. There's lots of things which are simple. We don't need new science here, but we just need to scale it up to reach billions.
David, you're raising an important question about the role of policy, right? What can governments do to facilitate some of these activities? And so, Diane, a question for you, since it came up briefly in your presentation. What is the role of the politician, right, in putting food on the table, and how do you envision that happening?
The role is bigger than I'm comfortable acknowledging because they seem reticent to do anything to improve the lives of people. All of these problems are on a massive scale, and they require people with different expertise working together. And if the role of government is to improve people's lives and to provide the basic needs for the people who are actually doing the work, to sort of have some sort of grand oversight, to put tools in place, money, resources, to have that sort of broad global view. And it's too sadly lacking, not just here, but in many countries in the world. I mean, there are better examples in some places than others, but it is, as citizens, we are aware of this, aren't we? And so, we can do all the science in the world. We can have citizens doing the right thing, and philanthropists helping that along. But you really need national and international organizations doing the right thing for the right reasons. And that seems to be asking a lot in 2023, unfortunately. I mean, you scared me with that slide. It just brought home the tragedy and the impending disaster and how it's playing out now. But when you watch TV, it's almost, there's this huge disconnect. It's incredibly frustrating. And I think I better stop now because I'm sort of getting...
I mean, Diana, what you're bringing up is something I think a lot about too, which is that one of the purposes that most people would agree is of government is to really solve those collective action dilemmas, solve those coordination dilemmas to work in the public good. And what greater public good than food, really around the globe for everyone. That is a security issue as well. I might expand this question out if Mengyu or David have any thoughts.
Sure. I mean, the ability to govern depends upon the will of the governed. And so, you know, we're staying in a hotel here in Cambridge where Washington marshaled the troops. And the revolution here was because of taxes on imports. And the inability to capture the value from your own land, in this case, the large historical forests of New England, which were so profitable at the time. And so in Plant Village, I really feel we're creating a global movement, and the only way to have the necessary change is through a knowledge-informed revolution, because the incentive structures are fundamentally misaligned. If you're on a 4-year election cycle, you're not going to do it. And history teaches this. The assassination of Patrice Lumumba in the Democratic Republic of Congo, or Jacob Arbenz in Central America, you know, driven by CIA policies or the Belgian government and so on, because of these inherent interests. And I also think that the international organizations have misaligned interests as well. Mm-hmm. So we're looking at, you know, $1 billion plus enterprises who have to keep on going. Mm-hmm. And so fundamentally it's about knowledge. But, you know, I was texting with a farmer this morning, 2 of them, and this is the connection that we have in real time. So it's absolutely possible to have that connection. And so the more people have knowledge, the more they're empowered, and the more they can change their direction. But it needs to be hundreds of millions of people. But luckily, the incentive structure is right for them.
Mm-hmm. Yeah. I very much agree, and I think for me, hearing whenever I hear experts and scientists and folk talk about what's missing, I actually become more hopeful because we're saying it out loud, which I think is really important. So I'll ask this question of Mengyu. Sometimes our climate change crisis can feel overwhelming. There's no doubt that it is urgent. What gives you hope that we can rise to meet the food challenges of the 21st century? And for all panelists, I'll throw this out to everyone after Mengyu. Please be specific, but Mengyu, if you have any thoughts.
To me personally, I don't have hope. We rely on technology improvement, and sometimes it takes some time. And climate change is so urgent, actually we have no time. So that's actually what I'm struggling every day, where I do research and it looks like I have hope, but actually I really doubt that.
Very much feel you on that. David, Diane?
It's depressing to hear that a young, intelligent scholar like Mengyu doesn't have hope. But I would look at her research and body of work to say that she is giving the keys to the kingdom. If you can understand the supply chains and how much it costs to move things from South America to China, then you can use that for disruption. So if you look at, you know, it was your inability to get a hotel room in San Francisco 15 years ago for a conference led to Airbnb. And so if you know the constraints in the system, you can invent new approaches. So what we're doing is working on the carbon markets, whereby not only are we increasing productivity, but I could have offset my coffee I bought this morning at Dunkin' Donuts to a smallholder farmer like Rosalind. So knowledge is empowerment with technology for the right solution. So I was somewhat hopeless, but I think, you know, given the size of the movement, I would also say, you know, like Margaret Mead, never underestimate the potential of a small group of people to change the world. It's the only thing that ever did.
I have shivers. Diane?
I wish we had ended on your positive note. I have hope that we will reimagine the future and that we will find a different path. I don't think what we're doing is sustainable. I think there's going to be some catastrophic event, and from that, we'll have to rebuild, hopefully with the knowledge that we've accumulated. So somewhere between, I think, these two guys.
All right, thank you so much. So now we'll turn over to questions from the audience. Thank you so much for your thoughtful answers to my questions. And as we've mentioned a couple times, you're welcome to use the Slido link shown on the screen and in the chat feature on Zoom to submit your questions. We'll get to as many as we can. All right. Now I'm looking at this for the first time. All right, so some really great questions here that I'm seeing. This is a really interesting one for Mengyu, and it touches a little bit on peri-agriculture, which I was hoping to ask you about. Are cities more efficient at food miles per capita than rural areas, and is it different in developing economies?
Yep. So when talking about peri-urban agriculture, it actually leads to one relevant scenario that we considered in our paper, that is localization. That is whether we can use technology to try to fix problems, especially specifically here is localization, for example. And the answer is yes. So this answer being yes is actually a new thing, because if we look at literature, if we consider specific commodity, food commodity, the answer could be varied. Sometimes yes, sometimes no. Sometimes localization is better, sometimes not. So by looking at the global picture, we show the answer is yes, but this reduction percentage is only 10%. That is quite limited. That basically means localization alone is not going to be enough. And we also need definitely a shift towards like plant-based food. But on top of that, we show that eating local seasonal available alternative is actually ideal, especially if we consider the difference of the per capita international food mile emissions between affluent countries and low-income countries. So that actually shows us something that we can do, like on our daily basis.
Wonderful, thank you, Mengyu. So I'm seeing a grouping of questions that essentially get us asking Diane to take us a little bit into the details of how her work is done at the genomic level on plants. There has been some interesting developments in the world of CRISPR technology. Can you tell us a little bit about CRISPR, whether you use it, what other developments exist? Take us into the DNA.
Okay, so yes, my lab, we use CRISPR-Cas9 technology to make specific changes in the genome. We usually have some idea about, what that change would lead to in terms of the trait of the organism. Essentially what we do is we take a molecular scissors, we can't see it, but we give it a little sequence that acts as a guide, and that sequence will take the molecular scissors to the area of the genome that we want to make a change. The Cas9 scissors will make a cut in that DNA, and then the cell must repair it. And in that repair, they may introduce some mistakes, an insertion of a nucleotide, a deletion, or a substitution. And that can then lead to a different protein, and that can then lead to a different function. So the beauty of this technology is that it's really a quick way to make a change in the genome. So I work on potatoes. A typical potato breeding program is 17 years. This is by making crosses and through selection. With genome editing, we could have a new genotype in 2 years. So it's really powerful, and that's what excites people, because we really need to design brand new plants really quickly. Is gene editing the only way? Absolutely not. Many of the methods that exist for improving crops are still important, still valid, but we're happy to have another tool given the urgency with which we need to develop new varieties. And the fact that we can sort of go after crops that are pretty recalcitrant. So, take long breeding cycles, a lot of time, and we can speed that up, gives me some hope. And sort of the newer technologies, well, we depend on our friends at the Broad Institute to come up with these new ways of doing gene editing. There's a lot more money in the medical field, and so for us doing research in ag, we sort of wait until they, do the testing, the hard work, and then we adapt and apply. There's not a lot of money in potato crop improvement. It's not a profitable crop to work with unless you have McDonald's as your as your market, to be honest. So our breeding program, we just use students and undergrads. We do it cheaply, but we're able to have a product, and so that's what excites us, the fact that the knowledge needed is such that citizens can get involved.
Amazing. Thank you, Diane. A really interesting question here about global food companies. I'm wondering if maybe, David, if you have any thoughts to start us off with. Can they be involved in the conversation, or how can they be involved in this conversation?
Yeah, so my work came out of my experience in West Africa. There was a young student here yesterday showing a cocoa game that she had developed. So I'm in Pennsylvania. So 97% of the value of a bar of chocolate goes to Hershey in Pennsylvania. And so I was working in rainforests in West Africa, coming out and seeing the decimation on a farm. We have knowledge for those diseases which are reducing by 40% the yield of farmers every year. And when I spoke to the international chocolate companies, the commodity traders, they said, well, if it gets to 60%, we're worried. And so they don't care. They don't care because they have other places to grow. So we saw the decimation of chocolate in Brazil through an act of bioterrorism from Da Silva when he was in the Workers' Party that launched him into being the president the first time. It then moved to West Africa, which is about 78%. Climate change is going to cause it to move to Indonesia, and they'll just keep on moving around. ESG largely and independently is failing. We know that absolutely. I'm a little bit more encouraged by some groups like Cisco, which we work with for tree planting. So there are some companies who are doing it effectively, but the fundamental problem is that they can go elsewhere and the farmer cannot. And that is the inherent problem here. If we look at the historical legacy of farmer profits in America and Canada, I think it's about 800% increase in profits at the farms over the last 20, 30 years. I may be wrong on this, but all of that is being captured by the middlemen. So the John Deeres and so on, and the providers and Monsantos. The massive consolidation of the industry from many companies into a few helps this price fixing, price gouging, so on and so forth. So none of this is optimistic, which is why farmers need lots and lots of knowledge, and through the work here, see what the market opportunity is. Because large companies, if we know one thing, is they're susceptible to disruption.
Yeah. Mengyu, I don't know if you have any thoughts.
Yeah, I have a quick one. So as a consumer, actually everyone has a role to play. For example, if we are able to consume less non-seasonal vegetable and fruits, and also animal products that are imported from countries very far away and transported by road or air. If we are able to figure out the supply chain, we are definitely playing a role to reduce emissions there.
Diane, I don't know if you have any thoughts on the question of food companies.
Lots. They're good actors, very few, and terrible actors. I know of a few small companies that are trying to do the right thing. Whether they can manage to do it or not is going to be dependent on if they can be profitable. And profits and what is right for people and the environment, it just doesn't always match. So we would have to build a new model of what profitability looks like within a sustainable sort of framework. So if we take, organic farming, for instance, at first glance, you may lose yield because, you can't use chemicals to coax the plant to produce as much as possible. But there's so many benefits for the environment, for the soil, long run for and people and nutrition, that it balances out. But at the moment, at that point in time, it's hard to see, or for some people to make that investment. And for the consumer, it's really expensive up front, but you're playing the long game. So those are the challenges that I think farmers and companies are faced with. They have to be profitable, and there's just a really ugly dilemma there, and I do not know how to fix that. Governments have to play a role. Governments need to invest more in agriculture. China is understanding the need for food security. They see that as almost as important as building the defense mechanism. It is impressive what they're doing in that country. And in the US, we're just like, it's really interesting to see that. So I'm not sure what the question was, but I said something.
It was exactly along those lines. So this kind of following on the heels and a little bit, and from what I'm seeing, but also bringing a kind of a two-finger on this. What I've been seeing some hope in the idea of traceability, right? That if we can trace where the soybeans are coming from that's feeding the cow in Vermont or wherever it is, that way we can incentivize better practices, right? When I think about the growth of AI, especially in the last few years, it seems that the technology is there, right? Blockchain could really do that for us. What is getting in the way? Is it simply kind of a logistical issue? What's the problem? Why are we finding it so hard to trace given all of our technology right now? And maybe I'll start with David. I don't know if you have any thoughts to share on this.
Yeah, we do a lot of stuff on blockchain for tracking carbon, for example. So technologically, it's easy. The phone makes it easy, and so on. But the reality of the situation are predominantly most people in America are not the ones in this room. And most people in America have not seen any increase in wages since the 1970s. But they have seen extraordinary proliferation of McDonald's in the local neighborhoods, which are driving down prices. And as Diane said, we had these food deserts. And so there's simply no choice if we're talking on the American landscape. So we grew up on welfare in Dublin, kicked out of school at 15. We're on butter vouchers, and we would go to the shop. And it is a luxury in my position to make a choice about where I want to buy things, but it is not the reality for most people. So this is where I think government actually is really important in order to push things. The European Union is very good in this space in order to push forward these policies, because people simply can't make the choices that we in our privileged position can make all day long.
Yeah, and those choices are sometimes even more expensive. Yeah. So not only do we need to know to make them, they are more expensive.
Yeah. And then the other thing, I was talking to somebody yesterday, we're blaming the victims.
Yep.
It's your fault, you can't eat. It's your fault, blah, 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 blah,
yeah.
blah, 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 blah.
Yeah. Diane.
So my understanding for blockchain, I don't know, it's not my field of study, but it's proprietary information and putting it out there and having it be susceptible to theft from other companies. So that limits the amount of sharing of data across entities. That was the limited understanding that I have of why there isn't more of the tracing and accountability along the food supply web.
Yeah. Mengyu, I don't know if you have any thoughts on this question before I go to the next.
I'll skip this one.
Okay, great. So this might be the, I think, final question, and I'll direct it maybe to Mengyu first, and then see who else wants to chime in. It kind of comes back to this question of politics, which I'm seeing kind of in many of these questions, and also in my mind as a political scientist who's studying messaging around food, because I ask why isn't it on the political agenda? Voter issue salience is there's very low voter salience around this, which is kind of explanation number one. But then explanation number two is about the fear of electoral backlash, putting a thorny topic like food on the political agenda. What are in your experiences working with so many different kinds of stakeholders? What have you found has been the most convincing way to message this issue or to communicate the urgency of this issue and the need for change? I ask because I'm testing some strategies too, so I'm curious about what ideas you can give me for framing this issue to voters and others. And Mengyu, yes, please, if we can start with Mengyu.
Yeah, I think I can mostly comment on how we can engage the entire supply chain players. In terms of policies, it's actually sometimes, to me, if we expand conversation to the entire supply chain, it's not only consumers, it's also about wholesalers, retailers, investors, and also governments. So how to come up with integrated policies that can really benefit most of the players, I guess, could be sort of contact point to make some relevant and really penetrationable policies.
Mengyu, thank you. You're making me sort of think about whether change is possible quietly. The Lancet in a paper has argued we need a social movement around food. It needs to be loud, but perhaps there's a way to start this process where we're using these kinds of integrated policies that kind of just start changing the food environment. David.
Yes, so it's extraordinarily difficult to get the messaging correct here. I think the behavioral economics is so critically important, the kind of thinking that Daniel Kahneman and others are doing in order to move people. You have a church in Harvard Yard, Memorial Church, and it was set up after the Civil War because a lot of people died, and we care about that. Over 1 million people died of COVID. Where is the church for that? And we were the best prepared country in the world for this. We had game plans there all along, and we simply ignored it because of behavioral science and the messaging. And now we fully accept that 1 million people can die, and we can just move on. And so what's the problem? So there's not a clear answer about how we have to do this, but it has to be a clear and actionable message that gets people involved. And it's not more science, and it's not more policy. It is the way in which you see this as a fundamental human right. And so they didn't kill Martin Luther King because of his I Have a Dream speech. They killed him because of his equalities messaging around worker rights. And so this is the fundamental problem. So we have television as the opiate of the masses. We have individuals kept in a stupefied state because people are playing out a game. And so it's extraordinarily difficult with climate change to alert people on that because it is that slow-moving crisis. But it's going to get a lot faster. And so then it'll become more real, and then we'll have behavioral change at scale. Good or bad, we're going to change.
Yeah, I agree, 100%. So I see this more in terms of messaging and culturally. We're such a siloed and segmented society. And I like the idea of integrated knowledge as well, but it just still has to be targeted so that what matters to one group of people is not going to matter to another. And so there has to be that targeted approach where people within the community can speak to what they care about. They can act as good ambassadors, messengers, and start the quiet revolution there. That's the only way I see possible. The messages about fats in this country can be so distorted and channeled to different groups of people. That tells you the enormity of the task of people like yourself.
Haven't found it yet, the messaging.
It is incredible. And this is probably, forget, global climate change and pandemics. This is probably the key issue, because if you cannot convince people of the truth or what's happening, then how do you even fix problems? So I don't know if that was positive or negative, but I'll just...
No, this is the truth. I'm biased, but I agree. This research agenda is a key issue to learn more about. Thank you so much. This marks the end of our first session. Many thanks to our terrific panelists, Diane, David, Mengyu. I wish I could take you all to a tea house and for us to sit around a table and just keep talking over hot tea. Thank you.
Thank you, Sparsha, Diane, David, and Mengyu. Very provocative session, and I will keep my remarks to the end, but I want to say that I remain hopeful, and to quote the Nobel laureate, we can call her now, she said to focus on what you can change. So we're going to continue to focus on what we can change.